Okay, so our objectives for this lesson, this would be lesson number 2, we're going to identify subatomic particles, and we are going to also determine number of protons and electrons and neutrons in a neutral atom and an ion, and we need to know the properties of subatomic particles, including their mass, location, and charge. So let's start with the vocabulary of the periodic table. So this is for carbon, the element carbon, and this is the standard one that you see as an example on your reference table, in the middle of your reference tables. This first number here is the atomic mass. And this is an average. Note that it has a decimal. That's because it is an average. It's not a whole number. And it is the mass of all of the isotopes of an element. Okay, so this is just for carbon, and every element has a few isotopes that exist in nature, and what they do is they take the masses of all of those isotopes and get a weighted average mass, and we're going to talk about how to calculate that in the next lesson. So oxidation numbers are over here in the upper right hand corner. And these tell us the possible charges that an atom can have. This is more important for bonding. Okay, so a carbon atom can be a -4 charge, a +2 charge, and a +4, and we will understand what that means in a little bit when we talk about electrons and the movement of electrons. Okay, the next thing here is this number 6, which is the atomic number. It tells us where it is on the periodic table. Everything is in order by atomic number. And it's the number, this is equal to the number of protons in every atom of that element. Okay, over here, this is the element symbol. We're going to squeeze this on this page here, element symbol. And it basically just tells us the letter that's used to identify an element. Used to identify, and let's give us some space here, identify the element. Okay, if you have any questions about this, you can ask me in class, but this is the terminology, and this is what everything means in each symbol box on the periodic table. Next, so let's look at this 2-4. Over here, the last thing on the reference table that you'll find in each element box is called the electron configuration. Configuration. Okay, and this basically tells us where the electrons are located and how many there are. So this is equal to the number of electrons in each energy level. If we add the numbers up, that will tell us the total number of electrons in the atom. So numbers, add numbers to get total number of electrons. Electrons, and I'm going to use the symbol E with the minus. Okay, and we talked about that before. So the symbol for electron, because they're negatively charged, we'll use E for electron and the negative for the charge. Next, so the subatomic particles. Sub meaning within, okay? And we talked about that prefix before. Subatomic can mean below, but this is going to mean within the atom. All right, so what particles can be found inside each atom? First one being a proton, which is a positive charge. The relative mass is about 1 AMU, which stands for atomic mass unit. And that unit is also found on your reference table. Okay, the location is in the nucleus, the central core of the atom. The symbol will be a P, and then we could have a plus for that, okay? And we will look at the atomic number to figure out what we have. Look at atomic number. It's the same. All right, next, neutron has no charge, so we're going to put 0. Let's go back up to the proton. I'm sorry, it should be a +1, okay, or a positive. And neutrons are 0, and their mass is also 1 AMU. Sorry about that again. Also found in the nucleus, neutron, nucleus. Symbol will be an N with a 0 up here, neutron. And how do we calculate this? It is the mass number minus the atomic number. And we're going to talk about how to get the mass number. It's different than the atomic mass. Okay, electron, a -1 charge. And this is very negligible. So electrons, not massless, but very, very small. So we're going to say 1/1836 of the mass of an AMU, okay? Negligible, meaning very, very, very small. The location is outside the nucleus in specific orbitals around the nucleus, and the symbol is going to be an E, or we can see E with a -1 here, okay, something like that, okay, E minus. And protons, number of protons is equal to the number of electrons, makes it a neutral atom. The charges balance each other out. Okay, so all the positive charges are equal to all the negatives, therefore it is equal to 0. Next. All right, so table O, symbols used in nuclear chemistry, and we're also going to use this to find out what the symbols are for each. So notice neutron, okay, neutron here, symbol, this tells us the mass, this is the charge, okay, and we use an N. Proton, generally is a P, okay, and the way I wrote it before is fine. This top number here for both is the mass, okay, this is going to be the mass number, or the atomic mass for those, or particle mass, I'm sorry, because they're not atoms, subatomic particles. So let's practice, okay, and we're going to do that on the next page. Let's say I give you a symbol, let's try chlorine 35. Okay, and isotopes, when we talk about it, are written in this notation, the element symbol with a dash and the mass number. So this number here tells us the mass number, and we are going to figure out number of protons, neutrons, and electrons. And when we look this up on the periodic table, chlorine has an atomic number of 17. Therefore, it will have 17 protons. Okay, so you need to look up 17. And we're going to look that up, and 17 is the atomic number, so we can put that there. Next, number of electrons, well, that's going to be the same, okay, because we just said number of protons is equal to the number of electrons. 35 is the mass number, So in order to get number of neutrons, we're going to subtract the number of protons from the mass number. So 35 minus 17 is equal to 18. That gives us number of neutrons. The atomic number, okay, we looked that up in our reference tables on the periodic table. It's atomic number 17. The mass number is indicated by this here, okay, and here's the nuclear symbol as we see it. Now, if you look this up on the periodic table, you're going to see a decimal. That's the atomic mass. In order to get the mass number, we're just going to round it to a whole number. Okay, so for the next one, let's do phosphorus. Okay, and when we look up the atomic mass, it is closest to 31. So we're going to round it to get the mass number. 15 is the atomic number. So the symbol, we're going to say P-31. Okay, and we're given the number of protons, so we're going to know that the electrons are 15 because they're equal. The atomic number we can look up, it's 15, and the mass number is 31. And when we subtract the mass number from the number of protons, we get 16. So that's where that comes from. 31 minus 15 equals 16. Carbon-14, this is an isotope. That's when they're depicted like this. So if you see a symbol with a dash and a number, it tells us that this is an isotope. This number is going to be the mass number. So let's go over and say, okay, so we know the mass number is 14. Let's write the symbol carbon-14 with a mass number. Oh, I'm sorry. Going too fast. Okay, so carbon has an atomic number. We looked that up on the reference tables. It has an atomic number of 6, mass number of 14. If you notice, the atomic mass is 13.998, something like that. So we round it to the nearest whole number to get the mass number, so that's going to be 14. Atomic number 6. Okay, number of neutrons. So again, if we subtract the number of protons from the mass number, we get the number of neutrons. The number of protons is equal to the atomic number, and therefore number of electrons is 6. We didn't really have to do any calculations for this one. Okay, next. All right, so the mass number is equal to the sum of protons, and I'm going to write it like this. Okay, P with a plus because we know they're positive charge. So protons and neutrons in an atom of an element. And we can just say P plus N is equal to the mass number as well. Okay, sometimes it's easier just to look at the atomic mass and round it. But if we're given the protons and neutrons, we can simply just add the two and get a mass number that way. The nuclear charge is a charge within the nucleus. And since protons and neutrons are the only two subatomic particles that are found in the nucleus, and neutrons have a 0 charge, then we can say that the nuclear charge is going to be equal to the number of protons. So equal to the number of protons or the atomic number, because they're basically one and the same. Right, so P protons is equal to the nuclear charge. So if I want to know what the nuclear charge is on carbon-14, I'm going to say it's a +6, okay, for carbon-14, because the atomic number is equal to 6, and therefore it has a nuclear charge of 6. It has 6 positive charges in the center, in the nucleus. Okay, next, atoms versus ions. So atoms are neutral, ions are charged. So this means they've either lost or gained electrons to give them a charge. Okay, so a neutral atom is an atom with the same number of protons and electrons. P equals E is a good way to say it. Okay, here's an example, carbon 12, or we can say just carbon itself, no charge indicated. Okay, we don't write plus anything next to the symbols. An ion, and we're going to talk about ions because there's two different types. An ion, and I always remember it this way with this line here. An ion means negative charge, or you could say N for negative, okay? Anion. So anions are negatively charged, and that means that the atom has gained an electron through bonding. Okay, to make it negative, because each electron is negatively charged. So gained an electron or more, one or more. The electrons will then be greater than the number of protons for anions. Okay, here is an example. If we write F with a -1, that means it's gained one electron. Okay, and there's the mass number and the atomic number. Fluorine is 9. The -1 indicates gain of 1 electron. Okay, so cation is going to be positively charged, so a good way to remember this is this little t looks like a plus symbol. Okay, so cations, an atom that has lost a negative charge to become more positive. So it has lost one or more electrons. Okay, and here basically I can give you another example. Here's lithium +1. When the charge is written, this indicates a positive charge with a magnitude of 1 or +1. Okay, same way I set it up here. So lithium +1, and then let's just put the symbols in here. So mass number and the atomic number. Lithium is atomic number 3. So you find that in the reference table. And next, a definition of an isotope, and we're going to stop after we're done with isotope. Okay, so an isotope, and these are can sometimes get confused with ions, but these don't have charges. Okay, so isotopes are atoms of the same element with different mass numbers. And therefore, they're going to have different number of neutrons, fix this here, and different let's put it this way, different mass number then means, this is what this is going to equal, different mass number means that we have the same number of protons but different number of neutrons. Okay, symbol for neutron, N, charge of 0. So here are some examples, isotopes of carbon, and this is how you will see them written. If it's an isotope, you're going to have the symbol and a dash and then the mass number. Notice how the mass numbers change, 12, 13, and 14. When you subtract 6 from 12, this is going to equal 6. Okay, so that's 6 neutrons here. 13 minus 6, 7 neutrons. And 14 minus 6 is equal to 8 neutrons. This is because a neutron has a mass of 1 AMU. So every time we have an extra neutron, the mass number right here goes up by 1, okay? That is changing the mass number in units, AMUs, by 1 every time we add a neutron. Therefore, it's going to change the atomic mass that we see on the reference table. All right, here are two more. We have U-238 and U-240. So let's figure this out. How many neutrons would we have in the two of these isotopes? Well, U-238, this is the mass number for this, and this is the mass number for uranium. So we need to look up the atomic number first to figure out how many neutrons we have. Okay, so after we look up the atomic number for uranium, the periodic table tells us that it's 92. So we're going to put that in here. Uranium has an atomic number of 92, and that's for all uraniums, okay, all isotopes. But the mass number has changed, so the 230 goes up here, the 240 goes over here. So it's going to change by, it looks like, 2 neutrons, right? 240 and 238, the difference is 2, so this is going to have 2 more atomic mass units because it has 2 more neutrons. So let's make sure our answer has that. So in order to figure out number of neutrons, we subtract number of protons from the atomic, or the mass number. Okay, so we're going to do 2, if this one's will work for me. Okay, 238 minus 92. And we're going to say equals here 146. So here we're going to say that we have 146 neutrons. Here, okay, as we can see that this has 2 more atomic mass units, that we're simply going to say that there's 148 neutrons. If you're not sure, you can do the math. Okay, 240 minus 92 equals 148. Here is 238 minus 92. Okay, and that's how we get that. Okay, so why does carbon have a mass of 12.011 on the reference table? This is carbon's atomic mass, which is the average weighted mass of all naturally occurring isotopes of carbon. So there exists 3 different isotopes, and we just looked at them in the previous slide, okay, 12, 13, and 14. Those are the common ones. And we'll see U-238 and U-240 are the 2 common isotopes. So the atomic mass that we see on the reference table is equal to the average weighted mass. And we're going to do that in the next lesson. So please, 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 please check out Quizlet.com over the weekend for vocabulary. You will have a vocab quiz next week. Okay, guys? So keep that in mind. Let's get going on that vocab. Okay, we're finished.